कल. So length into width, right? So I told you, okay, if one of the values is 0.200, it is accurate up to 4 significant figures, and the other value is accurate to just 2 significant figures. So your answer, use the least accurate significant figures. I mean, this is two significant figures, and this is your 4 significant figure value. So what's 0.2 into 0.4? That's, I think, 0.08. So your answer must be given up till 2 significant figures. Okay, so it's a simple rule. Okay, agar question ke andar you've got multiple values and each value has a different accuracy, use the least one. Okay, your answer cannot be more accurate than the least accurate value. And there was another point which we didn't discuss, and that was, okay, when you do a question, there would be multiple steps. Okay, for example, there's step 1. Okay, you do some calculations. Then there's step 2, you do some more calculations in step number 2. Then step number 3 is you use another formula, do another calculation, and then you finally get your answer, right? Now, when you're doing calculations in these steps, if somewhere in the step you get a value that's 1 point in your calculator, that's 1.333, and it just keeps on going, right? I mean, it would be better that you don't round off values in the middle. Okay, I mean, don't round off values. Like if you're calculating, if you're using these steps, you took one value, did some calculations with that, got another value, did some calculations with that, did another value, got some calculations with that. Don't round off things, or try not to round off things in the middle. In the middle. You can never do that because you're going to lose accuracy. Every time you round off things, your answer is going to be less and less accurate. For example, over here, just to give you an idea, I got 1.2435, let's say, in my calculator. So in the next calculation, if I'm using that value, I got 1.2435 and I'm multiplying it by some other value, which is 0.0800. I'm not going to round off this. Okay, I'll try to keep it as accurate as possible. Then I got some other value, and then I multiply that value by something. The final answer, I mean, the significant figure part should come in the final answer. Like when you write the final answer, that's when you should, or when you're writing the answer on your copy, that's when you round it off. Don't round off values on your calculator. Is this point clear?
Yes.
So if your calculator gives you a value which is 1.333 and it just keeps on continuing, keep that value on your calculator. Don't round it off over there in the next step. Use the same value. But if you were to write this on the paper, you're going to write it off to the appropriate significant figures. You're not going to write the whole value. Okay, so make sure, try and keep things as accurate as possible. Only round off those things that you're writing on the paper. Okay, or stating on the paper. So just make sure no rounding off in the middle of the calculations. I say, anyways, we were doing concentration. So concentration is moles over volume, or N is equal to C into V. We did that.
Sir,
Yes.
can you please just go over this once again about this liquid, solid, and gases? Like, I know the reason why solids and liquid and gases, their concentration doesn't change, but for the solid it does. Just can you go over it?
Okay, just more quickly, I'm going through it again. Okay, remember, concentration means when you say something is more concentrated, that means uska matlab ke particles are really, really close together, right? So that's more concentrated. And if something is less concentrated, the particles are far away. Now, the spacing between the particles only changes in solutions and gases. That's what I told you. So concentration represents the spacing, like how close together they are or how far away from each other they are. So this spacing only changes in solutions or in gases. Okay, if I add more water to it, the particles would become even further apart from each other. Okay, they would so they're going to be as far away from each other as possible. It's going to become more dilute. Okay. So my only point was that for liquids and solids, the spacing is always constant. It doesn't change. They're always together. So the term concentration does not apply to it. And the concentration, if you apply the term concentration, the concentration is always considered to be constant because the spacing is fixed. Is this clear?
Yes, sir. Thank you.
In a solid, you can't change the spacing. They're always tightly packed. And liquids are also kind of closely packed, not as tightly as solids, but closely packed. So, इस चीज का ख्याल रखना है कि never start calculating concentrations for liquids or solids. You're only going to calculate concentrations for solutions or for gases. Now, we did this formula, n is equal to C into V. I'm just going to do a couple of questions, just for practice. So if I have a solution, and that solution has 0.5 grams of NaCl mixed, and this is grams, and it's mixed in 50 cm cube of water. So the question is, what's the concentration of this solution? That's the question. So quickly calculating the concentration, it's going to be, for concentration, N is equal to C into V. So that means that C would be N divided by V. It's the moles divided by volume. I have the volume that's already given, that's 50 cm cube, but it should be in dm cube. So it's going to be 50 divided by 1000. So I found the 50 divided by 1000. That would give me the volume in dm cube. What are the moles? Moles is mass divided by mR. So I can find the moles. It's going to be 0.5 divided by NaCl is 23 plus 35.5. So those are my moles, mass divided by mR, which comes out to be 58.5.
0.5.
So I found the moles, I found the volume, these many moles in this much volume. So moles over volume, what do I get? And be careful with your calculator. If you're doing this in one step, put brackets, use brackets.
0.2. Exactly
0.2.
Yeah, it rounds off. It's 0.17. So.
Okay, so it's going to be 0.2. And why did you round it off to one significant figure?
Because the 0.5 is one significant figure.
Okay, because one of the values is just accurate up to one significant figure. So you don't know whether it's 0.51 or 0.50 or 0.53. So all the other significant figures are in doubt now. They're uncertain now because of this one value. So you're going to round it off to just one significant figure. That's 0.2 mole per decimeter cube. So that's how you're going to calculate concentration. You can find volume as well. Like if mass is given, let's say this 50 grams of calcium nitrate mixes in 500 cm cube water, giving a concentration of so it gives you a concentration, giving a concentration of let's say 0.15 mole per dm cube. So what you have to do is you have to find, just a second. So all you have to do is, एक second मैं rub कर लूं. So well, I've actually given you everything. Let's say I don't know what the volume is. So I don't know what the volume is. Find the volume. So to find volume, n is equal to c into v. So that means n is equal to c. So n divided by c is equal to v. So what I can do is I already have the concentration. I just need to find the moles. Moles divided by concentration would give you volume, and that volume would be in dm cube. तो इसका कोई मुझे बता दे कि what would you do? 50 grams, find the moles. It's going to be 50 divided by the MR. Calcium is 40. N is 14. O is 16. 16 into 3, that's 48 plus 14, that's 62. That's times 2. That's
the MR is 164.1.
Okay, so it's 164.1. So how many moles do you get?
Zero 0.300469 onwards. So 0.30 you can write.
So if you're writing this over here, because the values are accurate up to 2 significant figures, so I'm going to write 0.30. But remember, your calculator is giving you a much bigger value. It's got lots of numbers. Okay, don't change that value on your calculator. Keep it as accurate as possible. If you're putting it on paper, you use it up to, you round it off to the appropriate significant figures. Okay, but don't round it off on your calculator. The calculator has to be as accurate as possible. Okay, because if you round off values at every step, now you're going to do moles divided by concentration. So make sure you use the most accurate value that your calculator was giving you. So what do you get for this?
2.03.
Which would be 2.0, right?
Yes. Yes.
Okay. So the thing is, never round off values on your calculator. Keep the values, if you're getting 0.30 and there are lots of numbers after that, make sure you try to keep it as accurate as possible. I mean, you can either use the same value, save it on your calculator, you keep using the same value, or just make sure that it's as accurate as possible. Like you can go up till 5 or 6 significant figure, okay, when you're working things out. The final answer or any value that's stated on the paper, that must follow the appropriate significant figures. Okay, so don't round off things at every step. Just round off that final value must be up till 2 significant figures. That's it. Okay. So this is it. Let's do the final formula, which is gases. Is this clear? Any questions about this?
No.
Sir, can you do it again?
Which one? Your voice is breaking off. Can you type? Let me. No, the voice.
So,
Hanji.
Right? It is working off my certificate. You have to write like 2.0 decimal. You have to write the mole per decimal.
नहीं फिर से आप repeat करो.
Sir, V is the volume, right?
हाँ और सारी वो गलत किया है. एंड वाला तुमने देखा ही नहीं है. वो तो वॉल्यूम है. I mean, we're trying to calculate the volume, right?
Yes.
Aisha, can you type things? अच्छा, V was the volume. I mean, you have to be. I mean, this is one mistake that happens very often. It's a silly mistake, but make sure you get the unit right. I mean, when you're doing this quickly, you'll always forget what you were trying to calculate. You just calculate and you write wrong units. Make sure keep your eyes open for this. The next one is moles and gases. So when you have moles and gases,
So you're breaking up.
can everyone hear me?
Yes.
Okay, so try sitting closer to the internet, okay? So moles and gases के और एक वो थोड़ा सा मैं वो आइडिया दे दूं कि इस साइड पे बाय एंड ना इट्स काफी वो हाई एंड optic fiber is there, so most of the time if I'm breaking off it's you sitting away from the internet, okay? I mean that's the more likely situation, and I'm sitting very close to the internet as well, so वो देख लेना कि if I break off तो try and sit closer to the internet, ठीक है? अच्छा, this one, moles and gases, ठीक है? It's का simple, you can either use ratios. 1 mole of gas, it occupies what volume?
24 decimeter cube.
Okay, so it's 24 decimeter cube. But now you have to be very careful about this. Okay, only at RTP. Okay, only at RTP. क्योंकि आगे जाके ना what we're going to study is कि gases expand and they contract as well. I mean, depending on the pressure and compress. In O-levels, it was always 24 dm cube because in O-levels, you didn't study anything else. I mean, you always studied that gases were at RTP. Okay? By default, gases not being at RTP was not in your was not a part of your syllabus. So by default, you have a habit of thinking that 1 mole of gas occupies 24 dm cube. Okay? Now you have to change that habit. You have to read the question carefully, and you have to keep your eyes open, and you have to see, is it at RTP or not? Only then can you use this. Okay? So in ideal gases, when we study that topic, we'll study gases, if they are not at RTP, what happens to the volume. Okay? Which is, if you increase pressure, the volume decreases, and so on. If you increase temperature, the volume increases as well. So remember this, you have to keep your eyes open because you'll get questions that will be at RTP, and you'll get questions that will not be at RTP. Okay? In O-levels, you didn't get those questions. Now you're going to get those questions. So keep your eyes open for this. Okay? So you can't apply this formula every time. The formula is simple. You can either choose to use ratios. 2 moles of gas would occupy 48 dm cube. 10 moles of gas would occupy 240 dm cube. So you can either use ratios, or the formula is that moles is the volume of gas divided by 24 dm cube. And you can, the volume units must always be the same. It's either going to be, both of them should be in dm cube, or if you decide to take cm cube, then both of them should be in cm cube. So you'll find moles. So for example, if the volume of a gas is 48 dm cube, you divide by 24, you get 2 moles. So which is obvious that 2 moles of gas would occupy 24 decimeter cube. Is this clear? So what if I have 0.25 moles of oxygen gas? What volume would it occupy? Can you 0.25 moles? कितना आ रहा है?
6 decimeter cube.
So that comes out to be 6 decimeter cube. All you have to do is you've got the moles, multiplied by 24, you'll find the volume. So So anyways, it should be on your fingertips. If moles are given, just multiply by the volume, multiply by 24, you'll find the volume. If volume is given, just divide by 24, you'll find the moles. And be careful, is the question at RTP or not? TK, you have to keep your eyes open for this. This formula would only be applied if the gases are at RTP. This is known as the molar volume. The molar volume changes if the conditions change, because gases expand and compress. So he might give you a different molar volume. For example, at STP 0 0 degrees centigrade, I think the volume is 22.4 dm cube instead of 24 dm cube. So they might give you a different molar volume depending on the RTP condition. So the molar volume would change. Okay, so maybe a different molar volume is used if he's changing the conditions. So you just start using a different molar volume in the same formula. Is that clear as well?
Yes.
Yes.
But we're going to do the other types of questions later on, TK, not right now. Right now, we're just going to focus on this 24 dm cube thing. So we've done 3 formulas. Now there are other formulas as well, but we'll study those later. I'm going to jump to how do we use these formulas and what do you do in a moles question. So moles is the quantity, and the equation that you have, it gives you the ratio. It's like a cooking recipe. It tells you what amount must be mixed with the other substance. For example, I've got Na and I've got phosphoric acid, and it forms Na3PO4 plus it forms H2 gas. So there are 3 sodiums, and I think there would be, I think, 6 sodiums at the end of the day. There would be 3 H2 and there's going to be 6 sodiums. So I have the ratio in which they're going to react. And the ratio is 6:2:2:3. Remember one thing, that the equation is like a recipe. It gives you what quantity is going to be mixed with the other substance. Like 2 phosphoric acid will react with 6 Na. So it gives you the ratio, and it gives you the simplest ratio, the simplest whole number ratio. So moles, and it's the ratio of the moles. It's not the ratio of mass. Okay? For example, if I say that remember the masses, usually they don't have a ratio. For example, like if I give you a ratio that there are 11 people on one soccer team and there are 11 people standing, like forget the ratio. Let's say there's one person standing over here and there's another person standing over here. In a different room. What's the ratio? The number ratio is 1:1, right? There's one person here and there's one person on the other side. But the mass ratio is not going to be 1:1. This might be a very heavy person. This might be a very light person. Okay. So remember, the ratio of the number of particles does not translate into the ratio of the masses. Is this point clear?
Yes, it is.
So remember that the equation is the ratio of the number of particles. It's the ratio of the moles, not the ratio of the mass. Okay, so when you deal with these ratios, you're basically dealing with moles. And hopefully everyone knows how to use ratios. Let's say I've got 120 sodium atoms. Can anyone tell me how many phosphoric acid molecules would react with it according to this recipe? 6 reacts with 2.
40.
Okay, so that's going to be 40. And I'm assuming everyone knows this, that it's 6:2. Like 6 react with 2, so 120 would react with X, and you cross multiply, and that gives you X is equal to 120 times 2 divided by 6. That is 1/3 of 120, which is 40. TK, is this clear, everyone? TK, no issues. You've been doing this, TK, all the
Yes.
time. Acha, quickly tell me what's the quantity of phosphoric acid that would be produced, and H2 as well.
It would
Sir, 40 of phosphoric acid.
इसका नहीं क्या होगा? I couldn't hear you. This one would be
40.
okay, this one would be 40. I mean, it's 2:2. That means it's the same ratio. How much H2 would be produced if you're using 120 Na?
60.
Okay, that's going to be 60. Now, the simple thing is, this is time consuming. You don't have time to actually do crisscross every time. Okay, make sure you're quick. Okay, time is an issue. Okay, make sure you're very quick with this. So the simple thing is, if you know the moles or quantity of one of the substances, you can figure out the quantities of all the other substances. All you have to do is, if you know one of them, it's going to be 120 divided by 6 into 2. This would be 120. I mean, if you want to find this one, it would be 120 divided by its own ratio and into the ratio of the other substance. If I want to find H2, it would be 120 divided by 6 into 3. Okay, so let's do another one. Okay, I've got 6 NaOH reacting with 3 Cl2s, and they're producing 5 NaCls. Plus there is an NaClO3 as well involved, and there is 3 water molecules. Okay. If you know the moles of any one of the substances, you can figure out the moles of all the other substances in one go. So for example, I've got 0.15 moles of HCl. Now do this as quickly as possible. How much NaOH would be required to react?
0.3.
0.3. So it's basically 0.15 divided by 3 into 6. I mean, it's 1:2, so it's going to be 0.3 moles. Achha, what about NaCl? 0.15, take 0.15 divided by 3, multiply by 5. What do you get?
0.25.
So you're getting 0.25 moles. Now the other one you could, and remember you can use any one for the ratios. You can pick this one, 0.25 divided by 5 into 1.
0.5.
0.5.
0.5.
That's a 0.05. And what about the last one? That should be done directly. What do you get?
0.15.
Okay, 0.15 moles. Achha, so the thing is, okay, you can use any 2 ratios. Okay, the 5 things, they have a ratio with each other. You can connect any 2. Simply what you do is take the substance, divide by 3, multiply by this one, you get this one. If you want to find this one, you could pick these moles, divide by 3 and multiply by 1, you'll find this. Okay, so no need to actually go and explicitly do crisscross. Okay, make sure be as quick as possible. Okay, do a lot of things mentally. Okay, you don't have time, you're running out of time, so simply use this trick. So everyone try, and let's do another one. And I've got calcium phosphate. Plus water molecules, just a second. They're going to be 6 NH3s. I'm making the balanced equation. It's going to be 3 calciums and I think 2 ammonium phosphate. So we have this equation. I said this is, let's say this is 0.8 moles, 0.80 moles. Quickly tell me the moles of this substance over here. How much would this be?
0.02 or 0.03.
No, it can't be 0.03. It's
0.2.
0.8 divided by 6 into 2. What do you get?
Yeah, 0.2. Sorry, I put an extra 0.
Yeah, I don't get it. It's
I took 0.08 instead of 0.8. That's why.
अच्छा ठीक है, so 0.8 divided by 6, उसके अपने ratio से divide करो and then you multiply it by 2. So you get this thing, right? Remember, the original value was accurate up to 2 significant figures, so it's going to be 0.27, right? Is this clear?
Yes.
अच्छा, फिर what about calcium hydroxide? What do you get for that?
0.4.
ठीक है, so it's going to be 0.4. अच्छा, even if you, so it's going to be 0.8 divided by 6 into 3, right? If you had used this one, this is what I'm saying, that in your further calculations, you're not going to use 0.27. Like, keep the values as accurate as possible on the calculator. So if I were to find the moles of this substance using this value, remember when I wrote this down, I rounded it off to 2 significant figures. But on my calculator, I'm going to keep it as accurate as possible. So it would be 0.27 divided by 2 and multiplied by 3. And I'm going to get exactly 0.4. Okay? So there wouldn't be any rounding error. Because if I had used a rounded value, there would have been a rounding error. If I had used 0.27 and I would have divided it by 2, and then I had multiplying it by 3, I'm going to get 0.405 instead of 0.40. Do you get my point? Okay, keep your calculator as accurate as possible. It's only when you're stating those values or writing those values on your paper, round it off to the appropriate figures. So what about calcium phosphate? What do you get for this? 0.8 divided by 6 into 1.
0.13.
So you're going to get 0.13. I mean, on your calculator, you would be getting 0.1.
It's recurrent.
Okay, so there's going to be lots of trailing 3s. And this would be the same. It's going to be 0.80 moles. Okay. Now, all your moles questions are kind of the same. The only thing is you find the moles of one substance, you'll be able to find the moles of all the other substances. The rest is just formulas. They might ask you for the mass of this. You can use moles is equal to mass divided by mR and you can find the mass. They might ask you about the volume of the gas. You can use the volume formula and you can find that. They can ask you about the concentration of this. So you can apply the concentration formula. So the rest is just those 3 formulas. So all your moles questions are kind of, all you have to do is this thing. You're able to find the moles of one substance, you'll be able to find the moles of all the other substances. Okay, you have the other class. Let's continue tomorrow. Hopefully tomorrow we'll probably start with past paper questions of moles. One by one, topic wise. We'll do yield and other stuff later. There's a lot of other things involved, so we'll do step by step. We'll start doing the basic questions first in the past papers. Chennai, let's.
Okay, sir. Allah Hafiz.
Okay, take care.
Sir,
Yes.
Allah Hafiz, sir.
Allah Hafiz.
sir, kindly share them on the group.
Worksheet now.
Yes, sir.
ठीक है, मैं share कर रहा हूँ. Okay, Allah Hafiz.